the dam is underwater. From bedrock, the dam is 710 feet tall. If you could lift the dam out of the water and place it on top of the river, it'd be 10 feet higher than the bridge you can see in front of you. That shows us how much of the dam we can't see. If you look to your bottom left, you'll see a parking lot. On the right side of that parking lot, you see 4 concrete cylinders. Those are our hollow jet valves, or our bypass tunnels. That's how we take water from the lake and into the river without going through our generating station. This is one of the original turbines from when the power plant was first built. It was in use from 1965 to 2007. In 2008, they started a process of replacing all the old turbines with new stainless steel ones that are about 5% more efficient. They just finished that process 3 years ago. This turbine is 16 feet in diameter and weighs 45 tons. This is actually the bottom half of the turbine we're looking at. It's upside down. Now our power plant has 8 generators. That means we have 8 turbines. If y'all want to come take a look at these displays, we'll learn how this turbine works. Each turbine is surrounded by 24 wicket gates. This is a wicket gate right here. These wicket gates control the volume of water coming into the turbine, keeping it at the required speed of 150 revolutions per minute. 150 RPMs is the speed at which it has to be spinning in order to create 60 hertz of electricity. If you take a look at this picture, the water flows in through here, hitting the turbine. Each turbine is connected to a vertical drive shaft. Each shaft is connected to a rotor. All of our rotors are surrounded by 48 giant electromagnets. As the rotor spins, these electromagnets spin around hundreds of coils of copper wire, and that's what creates that electric pulse. To your left, we have one of our insulators, which goes on the back of our power plant and sends that electricity out. Sand. Fast forward to today, and we have petrified sandstone. During construction, they had a big problem with giant slabs of sandstone falling off. To counteract this, they had workers called high scalers, which we still have today, that would scale over the side of the canyon, drill into the canyon wall, and insert these rock bolts. They then poured concrete grout on the base of the rock bolt in order to tighten that hold. Now, this is a very short version of a rock bolt, which you see in front of you. The ones in the canyon extend anywhere from 45 to 70 in the United States, only after Lake Mead. When full, the lake is 560 feet deep. Today it's about 90 feet below that mark, about 470 feet. If you look along the canyon walls, you'll notice how it changes from whitish rock to red rock. That white rock is called our bathtub ring. That's where the lake would be if it was full today. So a natural part of our lake is that the water fluctuates. You remember I was telling you about that 8.23 million acre feet of water we have to send downstream. That number won't change. Sometimes we send more than that number, but we never send less than it. Arizona, Nevada, and California depend on the water we release. However, if we don't get 8.23 million acre feet of water from snowfall in the surrounding areas that flow into the lake, our water levels will drop. If we get more than that 8.23 million acre feet of water from snowfall, our water levels will rise. That's why we saw it. It's pretty impressive considering the size of the project in the late 1950s. The bridge stands 700 feet above the river, and at the time, it was the tallest standing bridge in America. Since then, multiple bridges have passed us at the Lake now. If you look to your bottom left again, we'll see that parking lot I showed you earlier. You also see an archway coming out of that parking lot. That is a 2-mile long tunnel that goes through the canyon wall at an 8% grade and ends up south of Page, nearby Walmart. The tunnel was carved out of the canyon during construction in order to bring materials and supplies down, and we still use it for that purpose today. The only way to go on that tunnel, if you're a civilian, is by going on the Wilderness River Adventure Float Trip. If you notice how it's bringing the water through the dam, this is where they level out underneath the grass. There's such a high volume of water coming through those pipes, it causes them to shake and vibrate. To absorb that vibration, they put a lot of dirt and rocks surrounding the pipes. They then planted the grass on top of the dirt in order to hold it down. It helps with cooling, and it looks a lot nicer. The grass is mowed every Thursday by one of our maintenance workers. It is an all-day project. If you look at the bottom of the dam near the middle, you'll see a small hole with water trickling out of it. You also notice that between the grass and the dam, there's about a 3-foot wide trough of water. That's all seepage water being collected. We collect 1,600 gallons of seepage water each fall. That's what's creating that vegetation, or we like to call hanging gardens. If you look straight up to your right, you'll be able to see the visitor center where we started our tour. We've since came down 64 stories, over 600 feet.
Is this a tunnel?
That's not a tunnel, it's just holding.
Okay, I got you. All right.
And it goes a little bit.
But it's just a stabilizer or something.
Generator weighs 440 tons and is 30 feet in diameter. If you take a step back and look up to this left corner of the room we're standing in, we'll see which generators are currently running. Looks like number 2, 4, 5, 6, 7, and 8. Generator number 1, which is closest to us, is currently undergoing maintenance. They're starting a process of replacing all the generators and putting in new ones that will be about 4% more efficient. If you look on the far end of the power plant, you'll see a large circular reddish-orange structure. That's our rotor. Each one of those rectangles that you see is an electromagnet. That rotor will be lifted up and placed inside generator number 1. Each generator can produce 165 megawatts of power, making a combined total of 1,320 if all are running at